6.1, having fun with 6.1. Roots and radicals, that's where we're starting off this chapter. Chapter 6 is 2 sections. We have 2 different chapter tests. So we broke it up. So if we have a variable and it's raised to a power, that power is odd, there's only one real solution. We're talking about real solutions. We know that we did get into imaginary, but for right now, we're dealing with real solutions. So if our exponent is odd, there's only one real solution. If it's even, remember that's why we have our plus or minus. 2 squared is 4, negative 2 squared is 4. Okay, that's where we kind of are starting off here. We're talking about just the real. We want to talk about the real solutions. Now you can do this on your calculator. The cubic root. So I'm going to show you on your calculator how to do this. If we want to find the cubic root, I'm going to show you 2 different ways to do this. If you want to go to, first, 0.008. And then if I go to math, oops, I actually should have typed that in first. Sorry. Go to math, then type your 4. So that's the cubic root, and then 0.008. If this was a multi-step problem, you would want to arrow over, but I don't have to. So my first cubic root is 0.2. 0.2. Now, because this is negative and this is an odd, cube is odd, we can still have an answer here. There's still going to be an odd, or there's still going to be a real answer here. Now, the other way that you could do this also is if I go to math. If you didn't see where I pushed math before, math. And then also you could go to this, if let's say the root was higher. You can type in 3 cubic root, and then negative 1,000. So that cubic root, real cubic root, is negative 10. The other way you could do this still yet is I'm going to put this as a fraction. So alpha y equals fraction. I'm going to go 1 over 27, and actually, I'm going to insert a parenthesis. I could still go to the cubic root both sides, but I also can do raised to, and this is what we're going to actually get into later on, but just kind of to show you, cubic root is the same thing as a fraction exponent. So a cubic root is a 1/3 exponent. So 1/3. Those are 3 different ways that you could get to the cubic root. If I want the 4th root, now this is where I have to be more careful. 4th root of 1, well, if you know your property of 1, it's just 1 times itself, each time is 1. 4th root of a negative 0.00001, well, I cannot take the 4th root of a negative. Then we're going to be dealing with imaginary numbers. So no solution there, sorry. 4th root, this is where you will start getting used to the powers of 2 and powers of 3, but just to show you it on your calculator, if I want to go to math, and again, my 4th root, so the little guy is the root, the index number, alpha y equals fraction 16 over 81. So my 4th root, there's 2/3. You should pause the video and try to do the 5th root and the square roots. Pause. So these I did in my head because you get used to it. But a 5th root, you can have a negative. 5th root, taking roots of 0 are always going to be 0. That one was kind of easy. 5th root of -1, you can still have a negative because this is odd. The 5th root of -1 would just be -1. So when you have an odd root, if you start with a negative, you should end with a negative. And my 5th root of 32 is 2. For D, real solutions. So if I put the square root of 0.01 on my calculator, I would get 0.1. If I try to do the square root of -1, I would get error. We know that is I, but we're talking about real solutions, so that's going to be no solution. The last one, the square root of 36 is 6, and the square root of 121 is 11. So now, finding the roots, and we only want real roots here. Whoops, you guys weren't supposed to see that. So looking at this first, I first have to think, okay, can this happen? If your index is odd, then you can have negative numbers here, if index is odd. So again, you can do this in your calculator, but I also know that 8 is a power of 2, or as a 2, so that's going to give me a -2. If I start negative, I should end negative. Square root of 0.04. Well, the square root of 4 is 2. And again, you can do this in your calculator, it would be 0.2. Here, the fourth root of negative 1. Well, this is even. I cannot take a negative root of, or I can't take an even root of a negative number. So this would be no solution. Here, here's a little bit different. You should work inside out. So really, if I were to rewrite this, negative 2 squared is 4. Now, because of that, I can take the square root of that and get 2. So when I have these, the index and the power here is the same, you have to be careful. I can't just cancel those out to get a negative 2, because in order to take the root of this, it had to become positive. So my answer here is 2. Pause the video and try to do the next 4 by yourself. So again, odd root, I can take of a negative 3. No solution here because I have an even root and the negative number, no good. Same thing with D here. I can do negative 2 or negative 7 squared to get 49, and then the square root of that is 7. That works. Can't do this, so now there's no solution. So looking at D and G. D and G, this is where we're getting to the next point. What if we have variables? What if we had an x squared, the square root of x squared? We have to be careful about something like that. So when I'm looking at this, again, what if I had something like this? Well, those two would cancel out, but we know because of this, looking at right here, my answer should be positive. So because my answer has to be positive, I would have to put the absolute value around it. That's what we're going to be getting into next. So D and G is looking at this property right here, nth root of nth powers. So if this is odd, it doesn't matter. If this is an odd index, it doesn't really matter because odds can be negative. If it's even, you have to be careful. So in other words, right here, big bolded, absolute value signs must go around variables with odd exponents in an even root problem. Oh my gosh, my Fishman, what are you actually talking about? Well, let me tell you. So looking at this one first, if you want to, some people like to do this. Some people like to break this up and go for it if you want, okay? I have an even index. If I take the square root of 16, I get 4. If I take the square root of x to the 4th, I would be looking at this. I'm not going to do this for each one, but I'm looking for pairs of 2. I have one pair of 2, another pair of 2. So this would be x squared. Now, because x squared is going to keep this positive, I don't have to have any absolute values, even though this is an even index. Now, another way to think with this, because my index here is 2, all I did was do 8. Oopsies, this is supposed to be 8. 1, 2, 3, 4. So I actually have 2 more. Sorry, I already did it in my head without knowing. So because this is a 2 right on front, I did 8 divided by 2. That's the same thing of how you can get the 4, because you have 4 groups of 2. So I don't have to have any absolute value signs here. So this would be my final answer. Here, I have an odd index. Odd index, for sure, I do not have to worry about absolute value signs. Don't have to worry about them because of my odd index. So now I'm looking at this. I take my index and divide it. So a to the 6 would be, if I would took the cubic root of a to the 6, 6 divided by 3 is 2. There's 2 groups of 3 in 6. So I look at my b. How many groups of 3 are in 9? Well, if I do 9 divided by 3, I would get 3. Again, odd index, doesn't matter about any of the absolute value. Here, I'm trying to cover up my answers so I don't cheat. So even index, now I have to be aware what's going on. First, I have x to the 8th. So I have to think how many groups of 4 in x to the 8th, or 8 divided by 4 is 2. Now I look at y to the 12th. Well, how many groups of 4 in y to the 12th, or 12 divided by 4, is 3. Now this is where you have to be careful. Because if, let's say, x was negative 1, well, here, x to the negative 1 raised to the 8th power would give me a positive 1, and then I could still do my 4th root. So negative 1 squared is still going to be positive, so I don't really care about this one, because the squared is still going to make x positive no matter what. This one though, wait a second. What if y was -1? Well, my original -1 raised to the 12th would give me a +1, and then I could take the 4th root. But here, if I had -1 for y here, -1 raised to the 3rd power, that would give me a -1, and then I could not do the 4th root. So right here, I would have to put absolute values around y cubed to make sure that this stays positive. So if you have an even index, and then you simplify and you have an odd exponent, you have to make sure to put absolute values of that so that you know it's always positive. I want you to try D, E, and F right now. D, E, F, D, E, F. Push pause, D, E, F. For D, square root of 81 is 9, and there's 2 groups. And again, if there's no index, that's always a 2 right there. So x squared. Because this is still even, I don't have to worry about absolute values. E, odd index. I don't care as much with the absolute values because it's odd. There are 4 groups of 3 in 12. So 12 divided by 3 is 4. For 15, there are 5 groups of 3 in 15. 15 divided by 3 is 5. Again, odd index, doesn't matter about absolute value. Here though, 12 divided by 4 is 3. It's kind of the opposite of this problem here. 16 divided by 4 is 4. So I really only have to have the absolute value around this x. So it looks kind of funny. So absolute value just around the x, y to the 4th. Let's say if you wrote this, if this was a test question, let's say, and you write this. Technically, you're not wrong there, but I will not mark that full credit. Just to let you know, that will not be full credit because this is the only one that we for sure need the absolute value around. So only put the absolute value around the terms that you know have to be there. And that is all we got going for 6.1. You have a grand day.